Okay. So, does anybody feel they actually understand this blockchain stuff now? Show of hands if you feel like you got it. Anybody want to come up here and explain it for me? Okay. So, I'm going to go back and really try and nail this thing down so that you wind up with an operational understanding of the blockchain that will allow you to correctly interpret its significance in your life, right? And to do that, we have to go back really 50 or so years into the early days of computing. Because what is making this so confusing is that most of the practitioners in the blockchain space have 50 years of history packed into their heads, which forms an implicit matrix in which words like distributed database hang. So to really get this to hang together, we've got to go all the way back, and we're going to go through this kind of quickly, but I want to try and lay out the foundations in the past so that we can meaningfully talk about the future. So we conveniently have this stage which is set out in lumps, and I'm going to make each one of these basically a 10-year span. So right back somewhere over here in the darkness of history, we've got the Second World War, which is where the computer was originally created, right? The computer as it currently exists was developed as a weapon to defeat the Nazis. It was used to crack the codes that allowed the Allies to paralyze the German war effort and eventually defeat them. And the link between cryptography and computation goes all the way back to the birth. In fact, if you go even further back, the analog computers, these monstrous brass devices which were used way back in the day, were actually created to calculate gunnery tables for naval ships at war. They wanted to be able to calculate the trajectory of artillery. So you come forward into the 1950s, and you get this kind of demilitarized computing. All of these machines and all of these engineers that have left the services and are coming in to, create a new generation, and we're going to take all this former military gear and we're going to put it in the hands of businesses. And back in this prehistory, the computers are the size of this room. They weigh tons. The guy from IBM famously says that there might be a world market for perhaps 5 computers a year, right? The data is stored on punched cards, and then eventually 1-inch wide magnetic tapes. And the complexity of these systems is such that it takes a room full of programmers to get a simple, reliable system to do something like process an invoice, right? This is the prehistory, and this is the mid-1960s that we're talking about. So the game really begins to be recognizable in 1970, when you get the creation of an abstraction called SQL in IBM by a guy called Cod. Edward Cod, I think? Anyway, Cod. So SQL is this extremely forceful application of mathematics to bring order to the chaos of tape machines. Back here, you've got a whole bunch of data basically just spattered across magnetic tape, and you've got huge machines that process the tape, but when you want to retrieve something, you have to go and fish for the data yourself. Move tape number 3 forward 17 feet, find me the record and give me back the first name. And programming these things is glacially slow, it's nightmarish. So here is the first place where the heavy math really enters the picture in this story, which is the SQL abstraction assumes that you create a multi-dimensional cube. 1 tape machine per axis of the cube. 5 tape machines, 5-dimensional cube. You can imagine it kind of hanging in space. You then have an abstract algebra which allows you to take a locus, a space inside of the 5-dimensional cube, specify it in ways which make sense to programmers fairly intuitively. See where there might be a gap there? And pull that set of data out into something that looks like a spreadsheet. And that conceptual jump was, at the time, so revolutionary, it took people about 5 years to accept that it had happened and that it actually worked. And what came out of that was the golden age of SQL, right? 1970 to 1990, just about all that we did was take every single thing that we could fit into a database in business or in the wider world, and we shoved it into a database. And right here, in 1970, the machines were incredibly expensive and incredibly fragile. The people working with the machines actually wore white coats, Because if you weren't wearing a white coat, stray fibers from your clothing could interfere with the tapes, jam the tape machines, and destroy all your customer data, right? So imagine this very fragile, very arcane, very expensive system. It's only just become technically feasible. These things are like laboratory artifacts, right? It's like going into, CERN or something like that when you want to inspect one of them. And this sets the mindset for databases. Right the way through 70s up until the beginning of the 80s, that's the psychological condition of the database. And the organizations become siloed because all of the information that makes your organization work is stored inside of one of these data temples. Right around 84, you get the microcomputer revolution, the IBM PC, the Apple, all this kind of stuff. And these are appliances. They're things that you can buy like a television and plug into your office. They are robust, they're reasonably cheap, as little as $4,000 or $5,000. Amazing, right? They are fairly easy to maintain and repair. They're relatively resistant to dust and humidity. They're pretty much like a television in terms of their operating characteristics. One per desk seems possible, and weirdly enough, they can actually run database software on them. You can actually have a database, kind of sort of like the big thing you had over here, but actually living on the machine that you have in front of you. And the kind of first real heavy use of an application that works in that environment is a thing called Lotus 123, which is the first spreadsheet. And this begins a revolution that goes all the way through accounting, but we're not going to talk about accounting too much. But if you want to think about computers and ledgers, starts here back in the 80s. Now, this is 15 years from, enormously fragile machinery and enormous expense through to it sits on a desktop. Can you imagine how disoriented the people that lived through that technological transformation were? It was just as weird as what's happening now, but it was happening somewhere over there because we hadn't invented the internet to bring you the news that something weird had happened with computers. Now we get to kind of 1990. The networking push really starts a long way back, but it takes a long time to get the networking stuff to work. 1990 is about where you begin to get networking that's practical for real stuff. I got my first email account in about 91, and at that point, there was no World Wide Web. There was a computer, there was email, there were chat programs, but if you wanted a document from another machine, you got an interface that looked a bit like a file browser, and you clicked on the document you want, and then it loaded it onto your machine, and then you opened it in something to take a look at it. And the notion that you could build the thing to read the document into the thing that got you the document was quite radical. That was sort of a big deal, and that was why the web was a big deal. Now, one more bit of weird paradigm stuff. Right? Over here, through this period, the computing is very much centered around data. It's structured, it's hard, it's rigid, it's formulated, it's tabulated. The stuff is very rigid. The web builds on a different model of computing, which is called document-centric. Right? Document-centric computers are paper simulators. Right? They hand you things which look like documents. You get email, it looks like a letter. You open up a graphics program, it looks like a canvas. There are things that look like paintbrushes. The entire model of computing that we're using right now is document-centric computing. And the connection between databases and that sort of data-centric computing and document-centric computing is extremely weak. They're two completely different ways of getting the machine to do stuff for you. And getting data into documents is tricky, as anybody who's ever done an Excel merge knows. And seriously, right, it's hard. Getting documents into data is even harder, which is the entire mess of content management systems. Right? Scanning documents, all of that stuff. These two things don't mix together at all well. So we come out through the 90s, and you kind of get to mid-95, maybe, early 96, and people suddenly realize that one day in the future you'll be able to make money on the internet. There's just one problem. There's no security, which means if you type your credit card into an internet form, it will be bounced all around the internet, anybody can read it, and they can steal money out of your account. It's another 5 years until we get a widely deployed solution that allows us to have encryption, which lets us move credit cards around the internet. E-commerce doesn't really become a thing until what, 1999, 2000, right? So we're already here by the time you've got a computer that is capable of taking a payment from, the internet. Again, how fast is the rate of change? Does anybody even remember when you couldn't put credit cards into the internet? I mean, you were all alive pretty much. But we forget so quickly what was possible or impossible when new technology arrives, we just kind of wash the memory out. It's quite hard even to think about what it was like before we had cell phones. So you come forward to 2010. By 2010, I'm going to suggest that more or less everything you could do on a web page had been done to at least a first approximation. More or less all the basic stuff was there. If you could do it with a computer that was basically a paper simulator, it had been done, more or less. Now, this is also roughly when Bitcoin gets started, and Bitcoin starts in some, festering little weird counterculture on the internet, which I spent my entire 1990s in, called cypherpunk. And the cypherpunks are straight out of science fiction. They can't tell the difference between science fiction and reality. They, generally speaking, have an emotional intelligence quotient of around 75 to 50. It took me a long time to grow out of that. And one of the things which makes that scene work the way that it does is the enormous prevalence of autism. So whenever you hear somebody ragging on the nerds, right? Whenever you hear somebody ragging on the nerds, remember what they're doing, generally speaking, is picking on autistic people, right? It's really important to understand that the people building the technologies on which your society completely depends, the people without whom the lights go out and the food stays cold, are heavily, heavily, heavily tending towards being on the autistic spectrum. So when you hear people laughing at the nerds, remember they're laughing at people that are disabled. They're also the people that your civilization depends on, so don't screw with them. Right? So the cypherpunks come out and basically say, in a very naive way, why do we need government? And they go and they build this thing, which is essentially a central bank of the internet. Now, you sort of think, well, that was a bit of a big jump. How did we go from, we can finally take a credit card to central bank of the internet? Right? That's what all of us spent about 5 years wondering as well. What the hell did they do, right? Because the technology arrived raw. We couldn't go and ask what Satoshi's intent was because Satoshi was a ghost, right? The software was dropped onto the internet, there was some early discussion, and then the guy vanished. So we have no idea who Satoshi was. We don't know what the intent was. There was nobody to go to conferences and pitch the technology. We were left with an artifact that, to all intents and purposes, might have been created by a time traveler and dropped. It's that big a jump. So what did they do? What they did was this, right? Back over here, the databases were singular. They existed in an atomic state, one database per enterprise. The network existed in some relational sense between enterprises, but because the database was perceived as being too fragile to let anybody touch, the database never directly communicated with the network. You always had lots and lots and lots of guards and buffers and other stuff in between to prevent the two things working properly. And if you did actually connect the databases kind of directly to each other, you got another problem, which was the database encoded the worldview of the organization. Two organizations, two different worldviews. You always needed something in between to translate. So you never got large-scale computer-to-computer connections that allowed you to create a shared model of reality between lots of different organizations. And this shows up every day when you try and do something like process a claim on insurance, and you have to fill in the name and address details 74 times for different organizations, often 3 or 4 times for the same organization. The databases are kept separate from each other, there's no real connectivity between them, and when you try and build connections between the systems, the complexity builds to the point where it's too expensive to do. So what they say, mean when they say the word distributed database, is a database which is both like a database and like a network. And this is the genius of Bitcoin. It fuses together the database and the network into a seamless whole called a blockchain. Everywhere there is data, there is network, and everywhere there is network, there is data. They're completely fused inside of these systems. So what that means is rather than having all of these individual kind of ivory tower computer systems connected by a network and then all the costs of moving things in and out, you have a single shared story of reality spread across all of the machines simultaneously. And when it changes in one place, it changes everywhere. And this is such a powerful abstraction, it's such a powerful technology, that the first thing they implemented was the central bank of the internet. That was the first thing they did. Can you imagine what Act 2 and 3 are going to look like? Right? You open by creating a single global currency, which is the first thing that has worked that way since we went off the gold standard, and the technology deployed is so powerful that it was done by either one individual or a small group that remained secret. They basically reinvented gold. And that was the first move. This is unimaginable strangeness to somebody that spent their entire lifetime monkeying around with computers. Oh my God, what have we done? So you get up to kind of where we are now, right? Basically 2015, 2016, we're sort of midway through the process. Bitcoin is well established as a reality. Everybody's comfortable with Bitcoin's existence to some degree. What is it? It's a bank account that stores magic internet money that comes from the central bank of the internet, which is a decentralized database which is everywhere and nowhere, maintained by a bunch of people you don't understand. But the funny thing is that if I describe to you how your government works, it's even worse, right? So every 4 years, we hold a popularity contest regionally. We pick the person that is most likable on television, more or less regardless of their values. We know nothing about them because they're protected by privacy that surrounds most individuals. So they could be a person playing a role. And then we assemble these people into a large group that gets to decide who lives and who dies every day. So, don't assume that because the new stuff is weird, it's any weirder than the old stuff. The old stuff is just weird stuff you got used to. Now, let me move a little forward to this whole smart contract thing, right? So, the smart contract is the third big integrative step. First, we merge the network and the database to make the blockchain. Then we take computer software, code, and put it into the shared database, into the blockchain. So we take a little program, and they can only be little because it's just the beginning of the story, and we take the little program and we store it in the blockchain. And that means everybody that's connected to the blockchain has the copy of exactly the same program, and programs, when you run the program, same data, same code, same result. So now, everybody's got a copy of the database, everybody's got a copy of the code, we all run the code at the same time, we all put the output back into the blockchain. If there's a disagreement, we find it immediately, we sort it out. So in that sort of environment, you have these little programs which are just as transactional as sending people money. It's like a wire transfer. You hit go here, the money flows across the network, it pops up there. It's like a Bitcoin payment. What kind of things do the little programs do? If this job has been done, pay Bob. If the job hasn't been done by the 31st of March, send the money back to Alice. Tiny, tiny little pieces of business logic pulled out of the application stack and put onto the blockchain instead. And this is the third big unification. I work for a company called Consensus Systems that uses Ethereum, which is the first really durable smart contract platform, to build lots of applications. And those little programs do things like make sure the artists get paid when their music is listened to. They do things like streamline transactions between banks. They do all kinds of simple, useful things, and we're still only at the very beginning of the story. Right now, the Bitcoin system processes about 7 transactions a second. The Ethereum system does something like 20. Right? So these are way back in terms of speed. They're way back over there where computers were in the 1960s on punched cards. Now, brace yourselves. Right now, the challenge is to produce a thing called a scaled blockchain. And a scaled blockchain is a blockchain that doesn't do 20 transactions a second. It does roughly the same number of transactions a second as Visa or SWIFT. 10,000, 50,000, 100,000 transactions a second, 250,000 transactions a second. And the scaled blockchain is something that begins to provide us with something that looks like a global computing surface onto which things like the Internet of Things could be loaded. You could take the entire global financial system and push it into a scaled blockchain. You could take the entire Internet of Things and push it into a scaled blockchain. You could take all of those machines in the cloud, you could put blockchain software onto them, as Microsoft recently did with a thing called Azure, and then you could have a single global computing surface that took all of our different bits and pieces of computing power and turned them into a global knowledge resource that basically manages the fundamental infrastructures of our society instead of the cobbled together nonsense that you get every time you talk to your bank. Right? And because these computer systems don't create new locuses of political control when they're built because they're decentralized, what you don't get is a position where the basic infrastructure of your society, the stack that your society runs on, is automatically owned by a set of corporations or even a set of governments. What you have is something which is constituted by the will of the people and serves their purposes, which is after all the original intention of government. Now, this is where we have to go back and separate reality from fantasy, because this is the mistake that's made it almost impossible for people to understand Bitcoin. Remember I mentioned the cypherpunks back here and their inability to tell the difference between science fiction and political reality? The notion that we're simply going to automate away all of the things which constitute government makes a ton of sense to people that spend 23 hours a day online, right? And I'm really framing this very carefully because this is causing enormous trouble. But if you're somebody that spends only a little bit of your time interacting with computers, it's pretty obvious that the computer only exists as a rectangle of glowing light somewhere in your room or in your hand, right? And out here, from that perspective, it's pretty clear that if you teach computers to govern resources, a lot of trivial stuff in your life gets a lot easier, like paying your taxes or making sure that your telephone works or doing your banking, whatever it happens to be. But it's not obvious that this is a replacement for the general edifice of government. And the tension between the way the world looks to the technologists and the way the world looks to everybody else is what's at the heart of the fight with entities like Uber. Because Uber makes perfect sense to a technologist, and it really upsets people that have run a taxi monopoly for 150 years. And those kind of discussions and tensions are as much about the different neurological makeup of the people who develop the worldview as they are about the technology. What we're really having here is a discussion about what kinds of minds run our society. Is our society predominantly run by charming, glib, slightly sociopathic people that look good on television? Or is it predominantly run by people that live in front of computers and control the world with numbers? Right? And that debate has gone on inside of our culture since the two cultures period of British history, where there was this discussion about whether arts and sciences could ever get along. Well, turns out the sciences guys are now figuring out how to govern instead of the lawyers, and this is creating an enormous amount of turbulence. But the turbulence is not well described because it's happening extremely quickly, and the only place that there's a literary canon that really describes these processes is science fiction. Right? If you want mental models of how to think about the reality that we're currently in, you have to go back to the science fiction of 30 years ago, published under a general title of cyberpunk. Right? And cyberpunk was the fiction that describes the reality that we're now in. It's about virtual reality, it's about drones, it's about biotechnology that regrows your nervous system. It's about virtual currencies and artificial intelligence. And we would all have a much better grip on the reality that we found ourselves in if science fiction hadn't been kicked out of the literary canon sometime after World War II. There's a definite push where science fiction is pushed away from the mainstream of literature and into its own kind of genre box. And as a result, the place where most of the thinking and analysis has been done about these technologies and what they mean to us as a society has been banished from polite company. It all exists in a place called genre fiction, and it's no longer considered to be real literature. As a result, the mainstream kind of arts population have been left without mythic narratives to allow them to interpret the reality that the technicians have created. And what we've seen this evening is a perfect demonstration of that gap, because actually getting the message across requires a completely different perspective to the one which is natural to the technicians. I'm lucky in that I've managed to bridge that gap because I was always as much a writer as I was a programmer. And I've done about equal amounts of both in my life. So the thing that I want to leave you with is this. The dialogue about how these technologies are going to fit into our society is going to be a dialogue about class. It's going to be about whether the society is run by lawyers or technicians. Both are the wrong answer. It has to be run by the people. But for the people to be able to intelligently make decisions in a society where the core technologies that run our society are rapidly becoming so complicated we no longer understand them, we have to do better than guessing which technocrat or which lawyer to put in charge. Without a fundamental reawakening of interest in science and technology, and without reclaiming science fiction as a fundamental literacy for the present that we're in, we're going to be left making decisions more or less at random depending on what charming person tells us the news story. So my challenge to all of you is start reading Cyberpunk. It's painful, right? It's painful, right? Much of it is not very well written. Many of the ideas look almost like it's kind of weird potboiler fiction about the present. But if you sift through carefully, and I'd suggest starting with an anthology called Mirror Shades, which is a short little book with short stories, nothing to challenge you too much, right? If you go back and read that stuff, what you could begin to flesh out is the stories that all of the programmers had in their heads when they built these technologies. And that's how you get your head around what's happening. If you share the myths that the technical class have when they create these things, you can begin to understand the technology in a mythic way, which is how we understand it. You have to learn the ways of our people because you're living in the world that we create for you.